In this video, we are going to talk about another kind of linear program, another advertising mix problem. In this one, we will be trying to maximize our return on investment from the spending that we're doing. And we'll have a target, a constraint of meeting a certain minimum number of orders, and then we'll have constraints on how much we can spend in different categories. So we're going to consider these four categories of advertising. We're going to consider search ads, Google, etc., Facebook, YouTube, and Gmail. You could add in whatever other media outlets you might like to consider, billboards if you're old school, TikTok, whatever, I don't know. If you have the numbers, we can make the analysis. And our goal is to maximize the return on investment of our spending. We want to get as much return on our investment as possible. We have a goal of getting at least 1,500 responses, and by responses, we mean orders. We have $15,000 we can spend maximum. Someone has decided that we need to spend at least $3,000 on Facebook ads and at least $400 on YouTube. Now, we might question whether those people knew what they were doing when they came up with those numbers, but for right now, we're going to trust them that they have their reasons, and we will see how to incorporate those constraints, those desires into our linear program. They've also decided that Facebook plus YouTube should make up at least 60% of the total spending. Somebody also decided that the YouTube spending should be less than the Gmail spending, and that Gmail should be less than 10%. And this is all based somewhat on this example that I've credited there from Khan Benjisu. Probably said that wrong, I'm sorry. So we have these four variables: search ads, Facebook ads, YouTube ads, and Gmail ads. So I'm calling them X1, X2, X3, X4. I could have called them S and F and Y and G, but I just decided to go old school with X with different subscripts. So X sub 1, X sub 2, X sub 3, X sub 4. Now our goal is to maximize return on investment. So we've already done the first step, which is figure out what the variables are. And the variables are how much we're spending in each of those categories, because that's what we can decide. We don't get to decide how many people will buy our stuff. We get to decide how much to spend on these different outlets. Now, what we're trying to do is we're trying to maximize our return on investment. Now, we're assuming that we have this information available to us from our past experience. For each of these four platforms, we know how much we spent, we know how many clicks we got, we know how many orders we got, and then we know what our revenues were. In a perfect world, we would also know what our profit was for each of those orders, but we don't have everything. But we have a lot of information here. So now the question is, how are we going to use this information to come up with the goal of our optimization project? One thing we could do is we could try to maximize the number of clicks that we're going to get. So we know how much we spent, and we know how many clicks we got. So if you take the amount we spent and divide it by the number of clicks, you could calculate a cost per click. It's a metric I think everyone's heard of. What's your cost per click? So in the case of search ads, it costs us 40 cents for every click we're getting. Again, I'm not saying these are realistic numbers. But that seems like we would want to minimize that. Another way we could look at that would be to flip that around, do the fraction upside down, and calculate the number of clicks that we get per dollar that we spend. So we could take the number of clicks and divide by the cost and realize, okay, we get 2.5 clicks per dollar spent. So theoretically, we could have set a goal of maximizing clicks, except that's not what we're trying to do here. We're not trying to, the goal is not to maximize clicks. The goal is to maximize net revenues. So cost per click is an interesting metric. And if you don't have the number of orders, and if you don't have the revenues, then really all you can do is try to maximize the number of clicks you receive. But as we all know, not all clicks are equally likely to end up in profitable sales. So if we have this additional information, we should use it. But if all we had was clicks and the cost, we could go this way, but that's not what we're going to do here. Another thing we could do is try to maximize the number of orders that we receive. So we know, for example, with search ads, we received 1,000 orders and we spent $8,000. So if you take 1,000 orders and divide by $8,000, we got 0.124 orders for every dollar that we spent. And if we didn't have the revenue column there, this would be a good thing to try to maximize, trying to maximize the number of orders that we receive. It seems a little odd to say we get every dollar generates 0.124 sales. I suspect if these were your real numbers, you wouldn't want to say multiply everything by 1,000. So you could say we get 124 orders for every $1,000 that we spent. That just seems easier to talk about. But again, this is not what we were told we were supposed to optimize. If we didn't have that revenue column, this would be a perfectly acceptable thing to optimize, but we have revenue. So let's work on that. Our goal is to maximize the return on investment. So what is return on investment? Hopefully that's at least vaguely familiar from your finance classes. So it's the net revenue divided by the cost. So it's not total revenue divided by cost, because it's possible a scenario where you spend so much money that you're not hardly making any money. So we're taking the sales revenue minus the cost and then dividing that by the cost. So for search ads, $225,000 minus $8,000 in advertising cost divided by 8,000, we get 24.58. So search ads yielded $24.50, call it 25 just for ease, $25 for every dollar we spent on advertising, which is obviously a better return on investment from any of the other ones. As I said earlier, in a perfect world, maybe we would know what the profits were from those ads, because really that's what we want to maximize, but we don't have that. So at least we can maximize our net sales dollars per dollar of advertising invested. So this is what we are trying to optimize. So it took us a couple of slides to get here, but these are the numbers we're going to be using in our objective function. So we have X1, X2, X3, X4, and we're trying to maximize total return on investment. And again, we get $24.58 for every dollar we invest in search ads, $18 for every dollar on Facebook ads, et cetera. So this is what we're trying to do. We're trying to maximize this sum right here. And I hope you all could stay with me on the how we got that return on investment. So two things done now. We've figured out our variables, which is the amount to spend in each category. And now we have our objective function. Now we need to just find our constraints and we will be ready to solve it. We have quite a few constraints, unfortunately. Some will be easier than others. The budget constraint, we only have $15,000 to spend. We cannot spend more than $15,000. That's not going to be too hard. We have X1, X2, X3, X4. That's how much we spend in each category. Add them all up, we can't spend more than $15,000. Facebook ads, that's just one variable. Facebook is X2. X2 cannot be greater than has to be greater than or equal to $3,000. And then YouTube has to be greater than or equal to $400. So those three constraints were really pretty easy to do. Total amount of spending has to be less than or equal to 15,000. Just add up the categories. Facebook has to be greater than or equal to something. YouTube has to be greater than or equal to something. Again, this is just the amount we're spending in each of those categories. So those variables were pretty easy. Now I'm going to jump down to that bottom constraint there. The number of orders has to be greater than or equal to 1,500. Then we'll come back to the other ones. So from a slide a few minutes ago, we figured out the number of orders we get from every dollar we spend on these different options. And our goal is to get at least 1,500 orders. So we can just take our spending in each category and multiply it by those numbers. So we will use them as coefficients. So, and I've just rounded to 2 decimal places. So for every dollar of X1 search spending, every one of those, let me get my pointer going here. Every dollar we spend on search will generate 0.12 orders. So 0.12 orders for every dollar of X1 plus 0.09 for every dollar on X2, etc. Would it maybe be better to use 3 decimal places? Yeah, maybe. But I didn't for whatever reason. So this is our constraint, that we have to get at least 1,500 orders, because we know how many orders we get for every dollar we spend, and just take those numbers times the dollars we're spending in each category. That all has to add up to at least 1,500. So we've got our objective function. We already had our variables. We have those 3 budgetary constraints. Down on the bottom, we have those responses. We just have those 3 in the middle. And those lines don't have any mathematical purpose, in case you were worried. That's just to help you see what we're doing. So let's look at those last 3 now. And they're not going to be terribly bad. So I'm calling them percentage constraints. Call them whatever makes sense to you. So Facebook spending plus YouTube spending has to be at least 60% of the total. Again, we're not here right now to debate whether that was a wise constraint, but it's one we were given. And our job is to just develop a model that will allow us to have the advertising plan that we were told to create. So X2 is Facebook spending, X3 is YouTube spending. If you add those 2 together, they have to be greater than or equal to 0.6 times the total amount that we spend. What's the total amount that we spend? The total amount we spend is X1 plus X2 plus X3 plus X4. So add those all up, multiply that by 60%, and you'll get some number of dollars. Then X1 plus X2 has to be greater than or equal to that total amount of dollars. So that might not look right because we have X's on both sides. We're going to clean that up in a second. I just want to make sure everybody understands the idea. The total spending on these 2 has to be greater than or equal to 60% times the total spending. So if we multiply out that 0.6, it looks like this. So now the things on the right side are 0.6x1, 0.6x2. But now, as I know you're already thinking, we want all the x's over on the left-hand side. So we subtract 0.6x1 from each side, and this is what our constraint looks like then. Minus 0.6x1 plus 0.4x2 plus 0.4x3 minus 0.6x4. That sum has to be greater than or equal to 0. Looking at the constraint that Gmail has to be less than or equal to 10% of the total, we're going to use the same exact approach, Gmail spending. So Gmail is X4. X4 has to be less than or equal to 0.1 times the total amount of spending. So multiply out that 0.1, and we have X4 is less than or equal to 0.1 X1, 0.1 X2, 0.1 X3, 0.1 X4. And then we subtract all those numbers on the right side from the left side. So we get negative 0.1 X1 minus 0.1 X2 plus a negative 0.1 X3. Obviously, I didn't need that addition sign there. I just didn't see it. And then plus 0.9 X4 has to be less than or equal to 0. So that's our Gmail constraint. And then the last one says that the amount of YouTube spending has to be less than or equal to the Gmail spending. X3 is Gmail, sorry, is YouTube. X4 is Gmail. So X3 has to be less than or equal to X4. And then we'll just subtract X4 off both sides. So we have both of our variables on the left-hand side. So this is what our linear program looks like in the end. We have maximization of the 4 variables, and then we have our budget constraints, then we have those percentage constraints, and then we have the total number of orders constraints on the bottom. So we've got it all together. We're going to put it into Excel. Again, just try to use the same convention to keep things consistent. So yellow is the variable information, the amount to spend in each category, and then the blue is the number of responses. And so this is the optimal answer. So we're going to spend $5,600 on search ads. Oops, 8,600, that should say Facebook. Made a typo there. That should say Facebook, and then YouTube, and then Gmail. I would go fix that, but it would take too long. Anyway, so let's go look at the results here. So the answer report says those same amounts. And then we can see that that budget constraint is binding, not surprising. We spent all the money. That the Facebook, where it said display, that should be Facebook again, my apologies. 8,600, that is not binding. YouTube, that is binding. We can see them all there. Looking at the sensitivity report, we are spending $5,600 on search, $8,600 on Facebook, $400 on YouTube, and $400 on Gmail. And the reduced costs are all zero because it was optimal to do all of these things. But the shadow price is interesting. So looking at the constraints, that total budget of $15,000, for every additional $1 you give me of budget, I would generate $20 in sales, net $20 in sales. So advertising is doing its job. Yay. YouTube minimum responses, you're cramping my style here with this YouTube constraint. We have to have at least $400 on YouTube. And if you increase that, every dollar you make me spend on YouTube, we're going to lose $33 in sales. That might make it seem like YouTube is not a place we should be, based on our experience, spending our advertising dollars. But maybe somebody has a grand plan and that's part of an awareness campaign and yada, yada, yada. And then YouTube has to be less than Gmail. For every unit increase you allow me there, we generate another $19 worth of sales. And then the minimum number of responses constraint, the shadow price is zero because we're generating more than the minimum number. So if you change that minimum number, at least change it a little bit, it's not going to cramp my style. So to summarize here, the goal was to maximize the return on investment of our advertising spending. So in order to be able to do that, we needed to calculate what the return on investment for the spending was. And we were only able to do that because we knew the dollars we spent, we knew the number of clicks, we knew the number of orders, and then we knew the sales. If we didn't have the sales, we could have settled for maximizing the number of orders. And if we didn't know that, we could settle for maximizing the number of clicks. But we have that sales information, so that's a more representative goal to what we should be doing. We calculated the orders per dollar spent in order to write one of those constraints. We had constraints about this spending has to be less than or equal to this much of the total. And then some, this has to be less than that. And then we solved it in Solver.